Good morning, students. Today I will take current electricity. You see, whenever two bad conductors they rub each other, due to friction, heat is produced between the two bad conductors, and that heat is taken up by the electron. They get energized, and they try to come out from one body to the other body. That is, electrons from the outer surface they are shifted from one body to the other body. It means there is an increase of the electrons, that is negative charge on one body, and there is a decrease of the electron that become positive charge on the other body. So a current is created on the body. Now it was found that the like charges they repel each other and the opposite charges they attract each other. Now here listen, two types of the currents are there. One is static, that does not flow, and other is the current which flow through the conductor. Now actually how much charge is there? That is, use the charge is equal to positive, negative, n into E, where n is the number of the electron, gain or the loss, and E is the amount of the charge. So if two electrons they are shifted from one body to the other body, then it will be 2Ne, and if three electrons they are shifted from A to B body, the charge will be 3E. Now unit of the charge is coulomb. It was found that the charge of the one electron is 1.6 into 10 to power minus 19 coulomb. Then we have to find out number of the electrons in 1 coulomb. Again listen, coulomb is the unit of the charge, and the charge on the one electron is 1.6 into 10 to power 19 coulombs. Then the number of the electrons in 1 coulomb. So number of the electrons in 1 coulomb is charge 1.6 into 10 to power minus 19 charge in 1 electron. Then in 1 coulomb, 1 upon 1.6 into 10 to power minus 19, that is 6.25 into 10 to power 18. It is the number of the electron in 1 coulomb. Listen, in 1 coulomb, number of the electrons we have to find out. Then this charge is on the one electron, that in 1 coulomb it is 1 upon 1.6 into 10 to power minus 19, that is 6.25 into 10 to the power 18. It is the number of the electrons in 1 coulomb. So number of the electrons in 1 coulomb is 6.25 into 10 to the power 18. So we say 1 coulomb has this much number of the electrons. Now we come to the current. What is current? In simple way, flow of the electrons per unit area in 1 second. Thus current is defined as the rate of flow of charge. Again listen, what is current? Current is the flow of the electron in a conductor, but it is defined as the rate of flow of charge. Now what do we mean by the rate? It means how much charge flow through a cross section in a unit time. So here I is current is equal to Q upon T, where Q is the charge and T is the time. And the unit of the current is ampere. Unit of the charge is coulomb. And time is 1 second. Now again listen. Current, that is flow of charge in a unit time through a cross section from a single point. Three things are there. Current is defined as the rate of flow of charge, that is simple language. But actually, flow of the charge from a single point of a cross section area in a unit time. So I is equal to Q upon T, where Q is the charge and T is the time, and the unit of the current is ampere A, unit of the charge is coulomb, and the time is 1 second. Then we will say that if 1 coulomb charge flow from a single point of a cross section area in 1 second is equal to the 1 ampere. So flow of the 1 coulomb in 1 second, that is known as the 1 ampere. So ampere is the unit of the current. So A is equal to coulomb charge in 1 second, which can be written in the form 1 coulomb S minus 1. So this is the current. So again listen, current is defined as the rate of flow of charge, means how much charge flow from a single point of a cross section per unit time in 1 second. Now, very important thing, what is the flow of the current? You see, when there was no discovery of the electron, it was said, if you see the simple diagram, that is circuit, this is the cell, and in the circuit we take a bulb or the resistance, then T, and it is joined, complete the circuit to the negative. At that time it was said that the conventionally current is flowing from the positive side, because current flow is from the positive. This is bulb, this is T, bulb glows, and the current is going back from the negative. So conventionally, current flow from positive to the negative. But if you see the conductor or a single wire, then current flows from negative to the positive. Because if you see this pic, it is a conductor, and in the conductor, electrons, they are moving randomly. Electrons, they are moving randomly. When current is passed, these electrons, a force is created in the electron, that is electrical force, and as the electron, they are negatively charged, they will immediately move toward the positive charge. This is how we say that if conventionally current flows from positive to negative, but in a conductor it flows from negative to the positive. Here if you see the cell, if you complete the circuit, then in cell, current is flowing from from negative to positive. Okay, so this is how we can define the current. So it will be clear to you. If you like my video, please share and subscribe. In my next video, I will take more concepts regarding the current, electricity. Thanks very much.